All right, hello everyone. You're tuned into today's PIR live event, and I'm your host, Scott Jones. Our guest today is Glen Kathler, who is an RFID certified professional and applied research chair at SAIT Polytechnic in Calgary. Welcome to the PIR live event, Glen. Before we get started, I'd also like to welcome today's viewers who are watching the live stream. It's great to have you with us as always. And remember that you can tweet us your questions at any time using the hashtag AskPIR. If there's room in your tweet, please include your name, school, or city, and we'll give you a shout out. So I look forward to getting to those questions, but in the meantime, I'll turn it over to Glen, who's going to tell us a bit about his background and the work that he does at SAIT.
Hey, good morning. So Glen Kathler, you heard Scott say it, research associate, which is sort of the new term for applied research chair. As you can see on the screen, it's the RFID Application Development Lab. And boy, let me tell you, it takes a while to get that all out without stumbling. So we usually call it the RAD Lab and RA for Research Associate. So it makes it pretty easy once you get to know me. So where are we, who are we, and what do we do is what we're going to talk a little bit about. So depending on where you are watching this from, this is where we are. We're, in the heart of the West, and obviously the home of the 1988 Olympics for those of you that are my age, and for those of you that are not. As you can imagine, a nice summer day in Calgary here on February the 16th. Oh, maybe no, this was actually taken last summer, so it's actually not summer right at the moment. And so we live in Calgary. We're at SAIT Polytechnic, the home of about 16,000 students. And I work in this department called Applied Research and Innovation Services. And so we do research on a variety of different technologies, and my specific area is the RFID Application Development Lab. So from the screen you can see Applied Research and Innovation Services. It's a very, very disruptive technology and a very, very disruptive environment. And so sometimes you really have to pay attention to what's going on, or you just never know what might happen. Okay, I'm back now. So like I said, you got to be on your toes when you're working here in the RAD Lab, and that's one of the reasons that, we keep pretty busy. We do a lot of activities with these UAVs or drones, depending upon what name you might like to call them. And they come in all different shapes and sizes. They can do all manner of different activities. And basically, our primary job is to see what can we do with these. These are really just a tool. They're a tool that people use in all different areas and applications. Pretty soon you might see your Amazon packages delivered by a drone. Drones can work in farming environments. Drones can work in, aerial imaging, in the movie industry, obviously in some industries that are not as public as others, as you can see by the display. And so it's a very new area of activity, and so what we're doing here, we have a fabrication area, so we can work at making drone frames lighter, more efficient, be able to integrate a variety of different electronics into these drones and UAVs. And one of the things with our RFID technology, where we're trying to track and identify assets in inventory, we're now trying to figure out how do we integrate RFID technology into these UAVs. So that's a very significant part of the research that we're doing. Again, if you follow any kind of news or newsletters or online feeds related to drones and UAVs, you'll see that basically they're used for all different manner of applications, and we're really no different, trying to figure out what those are. So that's going to transform industries with new technologies, new ways of doing things. So just imagine, we do a lot of work in Alberta in the beef industry. Oh, and here it comes again. All right, trying to track me down. All right. So UAVs, imagine flying over a herd of cattle, being able to read all the identification from each one of those animals, no matter where it is standing, where it is moving, and being able to do that automatically without human intervention. We've done some tests in the local industry, and we can get a drone to within about 10 or 15 feet of the animals before they even notice that it's present. So that makes it ideal for it being able to be very stealthy as it comes up and basically reads an RFID tag that would be attached to an animal and identify that specific animal. So we can also, again, do a variety of aerial imagery. So industry-based research here at SAIT, what do? Again, companies are trying to come up with new products, new processes, and we're trying to help them in that activity. And our students, like as I said, we have about 16,000 students here at SAIT, and students are into technology development, and we help them gain experience in that as part of their education. So if you come to SAIT, you're a student here, your opportunity to participate in this applied learning, work in one of our labs, is an awesome opportunity for any student who is on campus. And again, trying to help, obviously, the economy as we deliver new products, deliver new services, new processes. It allows the companies we work with to be, more competitive in their particular industry. So we do a lot of gadget building, and we have a lot of students who work in our labs. So typically we do between 2 and 4 students each summer, and then we often have students who work in the lab as part of their part-time job, typically during their second year here on campus. So it's a great opportunity for students to get involved and to build and play with things. So student projects, we do a lot of student projects at SAIT. So this semester, the winter semester, our lab will typically mentor between 25 and 30 students who are working on projects. And a project could start like this one, which is basically just a Google Sketch drawing of what someone thought a nice RFID controlled robot might look like. And then sure enough, once they actually built it, it didn't look exactly the same, but it certainly, that drawing was the fundamental beginning to that particular project for the students. So that's pretty standard during the 4-month winter semester for students working on capstone projects with my team. We have students from all around the globe here on campus. Again, as I said, we do a lot of work in the beef industry, and the International Livestock Congress brings students from typically Australia, South America, and Europe here every summer, and they spend a little bit of time here on campus with us, getting to learn a little bit about what we're doing in their industry with technology, and trying to guide them and teach them and show them a little bit about the RFID in their particular industry. So it's a very, very vibrant, lots of activities, lots of different gadgets that we're building. And just here's a few numbers around some of the things related to the industry-based research that we do here at SAIT. As you can see, we get a lot of government funding for grants, a lot of funding from industry. SAIT funds a lot of the project activities. You see the prototypes we've developed. And really the bottom line is this: we have a lot of students involved in our applied research, which is really our number one innovation. I like to say at SAIT, our biggest innovation is the students. And that's really what we try to work at and we drive toward no matter what. So just a little snapshot on some of the projects that we've kind of finished up. We built a cattle tracking system in the Alberta beef industry to kind of show how some of the new technology might benefit their industry. And so we proved the use of UHF, ultra high frequency, RFID, radio frequency identification, for being able to track cattle as they go throughout their lifespan in the beef industry. We work in, obviously, the markets that we have in Calgary and Alberta. In the oil and gas industry, we work with a company called GEM Solutions to do a mat-based RFID tags. Again, what are we trying to do? We're always trying to find stuff. We're trying to find it, locate it, identify. And that's basically what we use RFID technology for. In this case, these mats are buried in the mud when they're put out into the field and in use. And basically we were there to try to see about helping to identify those assets, things that have value. Companies want to know where they are, what they are, and how many they might have. We've worked with wireless apps for a thermostat project that we recently completed, and again, basically took a thermostat and made a complete software-based model of it to actually test it in the lab, make sure that it could do what it's supposed to do, that it could talk to cloud-based software to upload your personality from your home, from your thermostat. So we've done that for a company. So lots of different options. Again, students and lab team always busy working on things. Some of the new projects that we have underway related to that cattle tag I mentioned earlier, we're now combining it with a DNA tag. So basically this tag will not only collect the DNA from the animal, but will give that animal an RFID tag number, and it'll allow those characteristics for, you know, future animal breeding and future herd activity to be able to make better business choices going forward. So that's another one of the things we have going on. And if I can show this on my screen, I'll do my best. We build gadgets. So here's basically a gadget that we've just recently built for one of our projects. Comes in a little case. It's battery powered, has an antenna on it. For those of you that have a laptop, it's got a Wi-Fi hotspot on it. It's got a 3G modem, so it can talk through a cellular network. It's got a temperature sensor. It's got a humidity sensor. It's battery powered, and it can run for 24 to 36 hours on one battery charge. So as we go out and do field trials, basically, and again, students have worked to build and assemble this particular item. It's got GPS, so it knows exactly where it is. You set it outside, turn it on, and it can immediately report exactly where it is. So for a lot of our projects, the hardware that we want to use does not exist. So we basically will simply build it right from scratch. We'll build custom hardware for virtually any and all of our project activity. And if you're interested in coming to SAIT, we have a big open house, October 28th and 29th of this coming up year, and lots of kids from high school and all over schools come to check it out, see what going to SAIT as a student is going to be like. And you can see the link to our Applied Research and Innovation Services website, and we've got a lot of YouTube videos on there, so you can get an idea of some of the other projects that we have going on, who some of our research teams are, some of the students who have worked on projects, and we'd be happy to, you know, chat with you about any of the things you might be interested in doing. Scott.
Great. So lots of interesting stuff there for sure, and it's great to hear that students can get involved the way that they can. We have a few questions that are coming in. I'd like to say that we were watching your PowerPoint presentation there, and we missed the drone the first time. Is there any chance we can see the drone again?
Yeah, it's going to come by here shortly. So yeah, just as I disappear from the screen, you'll probably hear the sound of the drone coming in. So yeah, we just you know, it'll be starting up. Probably takes about 10 or 20 seconds, and it should probably make a reappearance.
Okay, very good.
It was actually heading back to the North Pole to help Santa Claus get ready for next year.
Oh, okay, it's very early. Lots of time left. So what does that drone do then? Is that the drone that's picking up the signals from the RFID tags then, or?
This particular drone we use mostly just sort of for training in flying. So it's a nice little quadcopter. It's very light and very easy to control. So it's basically just really the training instrument for teaching us how to fly. As you can see, even though I'm only standing about 3 feet from the actual camera, it's able to fly back and forth in a pretty controlled area, and away it goes. So yeah, the smaller ones are great for learning how to fly, easy to maneuver, and relatively safe to fly indoors.
And you're saying that students were responsible for putting that together then, eh?
Yeah, and students have built a variety of the different drones that we have in our lab. I could have brought a whole list of them out here, and one of the things that our students did last year is we wanted to control multiple drones from a single laptop. So the students built a software application so we could actually control multiple drones from one place, as opposed to having separate controllers for each one.
Okay. You talked about a number of different applications for this sort of technology. I'm wondering as far as humans are concerned, have there ever been tags inserted in humans?
Certainly in the I guess I would call it the public safety environment, there's quite often tags attached to certain individuals to track where they are. Most of the tags inserted into humans have been done typically by researchers who want to figure out how it's going to work. So we don't have anyone in my team right now who has one, but previously we had an individual who decided, he'd be happy to test out one of the subcutaneous RFID tags.
Okay. And how big are the actual tags then? What is their size? How small can they be?
The tags for basically the subcutaneous version would be probably like the size of about 2 grains of rice once they were, boiled. Not when they came hard out of the bag, but once you boiled them, you have something that's about a quarter of an inch long and, roughly about half of that in diameter.
Okay. And do they store data on them, and then you retrieve it later, or?
Yeah, typically they're just sort of programmed with usually a write once, read many times. So normally they're just programmed with really like a license plate. So it's somewhere in a database, that license plate is linked to, your pet, or, because that's the typical application that we would see in Canada is the pet tags that you would have from a vet. So it would be associated in his database to that particular animal.
I see. Okay. You talked about putting these tags on cattle, for instance. And I guess tracking the cattle from farm to fork is the tagline that you use, right? What are the advantages that you gain from being able to track a single animal information?
Well, you have several. Obviously, in Canada, we have a mandate for traceability that comes from the Canadian Food Inspection Agency. And so be able to know exactly all of the points of movement of that animal is very important, obviously, for record keeping for the owner at a particular time, to know how much weight that animal may have gained while in a particular industry or a company's possession, as well as when it actually goes to become that nice steak on your plate. We want to be able to track that. And the bottom line then comes back to what happens if there is some form of a disease outbreak. How do we trace back to know which animals the animal in question was in contact with? That's typically how that quarantine works, right? We start with an animal that is diseased, and we have to quarantine out from there. And so being able to track those animals reduces the impact on certainly the Canadian beef industry should that happen.
Okay, that makes sense. Can you give us a bit more on the basics of RFID technology in terms of the tag itself? Is it just a passive process, or the tag sending out signals? Is it an active thing?
Yeah, no, good question. Tags typically can be passive or active. Obviously, a passive tag is in the order of, a few pennies to a few dollars, whereas an active tag, which is really a radio, it's called a tag, but it's actually a complete radio, which might make it $50 to $75. So it now really depends on what do you want to tag and where do you want to track it, right? So that's really, it always comes down to the application. And the passive tag is a very simple, has no battery, it's just a chip with a little antenna that could be either wound into a coil or extended, the size of a popsicle stick, and it's basically energized when it passes into the area near an RFID reader. So an RFID reader is broadcasting energy all the time. These tags harvest that energy, and once they've harvested enough energy, they wake up, and they reply with their ID or their license plate number to the reader, which says, I just had a read, here's the time of day, here's the antenna that read a tag, and here's that tag ID, and I can now pass that upstream to an application that's looking for all of these tag reads.
Okay. So I could keep going with the questions here, but I'll see if we have anything from our students. It looks like we have one from Dr. G.J. McGillivray's school, and they simply want to know, it must be a young student here, wants to know, how young were you when you began researching?
Well, I think I was probably, I wasn't a teenager yet, that's for sure. I started building electronics gadgets when I was about 8 or 9 years old, and someone's been kind of paying me to do my hobby for the last 40 or 50 years. So research and trying to figure out how things work and how to make them work better has been something that has been virtually a lifelong adventure. Okay.
Generally, where do you see this technology going in the near-term future then? Where do you see it branching out into?
Oh boy, well, the ability, again, as all electronics, RFID tags, no exception, continues to get smaller and requires less energy to function. So once you take that, and then you take sort of the electronics that might manage or read or keep track of these tags, also starts to require less power. All of a sudden, we come into this technology, or this term we're hearing, called the Internet of Things, where all of a sudden perhaps an RFID tag could actually communicate with another RFID tag all on its own. And imagine if you had a virtual, what I call a mesh of RFID tags. So you might only have one tag out of 1,000 might actually be able to talk to a reader, but because every tag can talk to another tag, all of those tags are still part of the red family, as it were. And so I think that's one of the areas that this technology is really going to go in the next few years.
Okay. And I presume that these things aren't really susceptible to distance constraints too much, or if you have it underneath clothing, or if it's blocked in some way. Issues.
Again, the environment, as I said earlier, what do you want to tag, right, is always the first question that we ask. And certainly some of the technologies, if I take an RFID tag, I have actually a couple on my belt that I use at work. One is actually a UHF RFID tag, which is very similar to what you might find on a cow or on a name badge for somebody who's going to an event. I have an HF, a high-frequency RFID tag that's used to let me into our server room as an access control. Different technologies for different applications. So you have to always take that into consideration. But yes, you see now, like the one that I showed you first, this example here, I'll show it to you one more time. If I can get the picture in there, I got to go backwards to the way I think I want to show it. You might see that on a ski badge. All right, so a season pass holder at a ski area, he can have that badge under his parka, and as he comes up to the lift, it can read his tag, open a turnstile, and allow you onto the lift without any user intervention. So yeah, it can detect you, and that's one of the applications certainly for the user-based RFID tag.
So you hear a little bit about, so you talk about skiers having these, maybe using it as airports for identification, or football players using them in the NFL to track the players. Are there some privacy concerns that eventually become concerning, having all this data on people's whereabouts?
Well, certainly privacy is always going to be a concern. In its simplest form, again, the RFID tag is just a number, right? So if no one has reference to that number, and it really becomes down to if it's just some, if it doesn't, I'm trying to think of best way to describe this, if it doesn't allow me obviously security access, so my security badge, obviously I would be concerned if, say, someone might clone this. But that badge, you would need to be like virtually in my pocket to clone it, right? My other badge, my UHF badge, is really, again, it's just a license plate, and there's nothing that it does that is really connected to any of my private, my private information. So someone could read that tag from 20 or 30 feet away and said, wow, I got a 24 character number. Now what am I going to do with it? Like, it doesn't have any reference. And
I see.
And the passive technology, kind of a good segue, is that the next iteration of RFID tags and readers will be able to authenticate one another, so that my tag would actually be able to sense that it's being interrogated by a reader and say, is that a reader that I trust? If I don't trust it, I won't respond.
Okay.
And the same goes the other way around, that readers will be able to authenticate tags and say, okay, I've just read these tags, but one of these tags that I just read is not actually one of the tags from my family. So I will ignore, that particular tag. So that's sort of the next stage of RFID tag protocol and programming that is now a standard, but it still has not been implemented yet fully by any of the manufacturers.
Right. And I guess these things will be a bit slower to develop. They'll come with the rest of the technology, right? Once we come across these problems, then we'll have to come up with solutions, right?
Yeah. Yeah, it's very, what's the problem we're trying to fix? And, what's the best tag? What's the best technology that can fix that?
Okay. So as you're tracking these tags, is it fairly real time then that you're able to collect the data from them, or is there a bit of a delay?
Yeah, again, a tag has to go into the area, where there's a reader, and once it's energized, that information that the reader collects from the tag is instantaneous. Like I said, it'll have a timestamp down to, a hundredth of a second as to when it read that tag, and that timestamp, goes with that tag read. So we know exactly where this tag was at a very, very precise point in time.
And is it mostly researchers that would be using this technology, or I guess it's widespread, right? It's governments, it's everything, right?
Oh, for sure, very widespread. If you take the retail industry, not quite as much in Canada as, say, in the United States, but, there is now basically tens of billions of RFID tags in retail garments, throughout the globe that are being tracked from the time they're manufactured until the time that they're sold in a storefront.
Okay.
And that's probably the biggest adopter so far of the UHF RFID technology is the retail apparel industry.
Right. Oh, that's very interesting. Another question on Twitter here. It looks like it's coming from the Dr. DJ McGillivray again. And they say that their class is currently working with an Arduino device. I don't know if you've heard of that, but they're interested in ideas of possibly incorporating RFID tags with Arduino.
Yeah, typically that's actually not too difficult of a job. We use a variety of Arduino-based and Arduino, I guess, sort of relative components. That little case that I showed you has a Raspberry Pi in it, which is basically a very similar platform to the Arduino. And we use probably 3 or 4 other ones, Dragon boards, just to give out some of the names. Dragon boards is probably one of the newest ones. Udoos, very, very small ones. So again, for us, what size, what's the size and what's the application that we're trying to build. But there are some, software libraries online typically that if you want to play with an RFID tag and an Arduino board, you can get most of the code that you would need.
Cool, very cool. Okay, so we're almost out of time here. Maybe I'll give you one more question. And I know you talked about it a little bit with your slides, but in general, what advice would you give to our students listening in today if they wanted to get involved with this sort of work?
Well, come to SAIT. That's obviously the first thing, right?
Yeah.
But yeah, I mean, any post-secondary, certainly, colleges and universities do a variety of different types of research. And I think if a student, has an interest in a particular area, it's very easy now to do a little bit of online searching to see, what schools, what schools kind of specialize in which technologies, and and it's pretty easy, I think, then to kind of streamline, what someone's options might be as they go through, into junior high and into high school. But certainly, if you're in the neighborhood, come to the SAIT open house.
Great, good to hear. So hopefully everyone got the message then, and they'll give you some research and check that out. Unfortunately, though, that's all the time we've had for today. So I'd like to say thank you to both Glen for answering all our questions today, and then everyone who sent in all their questions over Twitter. So before I let you go, Glen, I'll just give a quick pitch for our event next week, which is this week actually, Thursday, February 18th. And we'll talk about the tree bark biorefinery project with Dr. Ning Yang from the University of Toronto. So that'll be good to hear about that. So thank you again, Glen.
You're welcome. Thank you.
Talk to you again next time.
All right.